So much and great. And thank you so much. And so honored to be here today with Andre and the team at dstack on this webinar hosted by the Linux Foundation. I'm Kevin Cochran. I'm the Chief Marketing Officer here at Vultr. Andre, do you want to introduce yourself as well?
Sure, thank you, Kevin. Yeah, it's a pleasure to be here today and speak about dstack. So can't wait for it.
Great. Thank you so much, Andre. And here at Vultr, we could not be more excited about today's topic, and we could not be more excited about DStack. I personally am super excited to see Andre's demo today. For all participants, I purposely did not review Andre's demo so I could share the same amazement and wonderment as all of you real time here on today's call. But before we begin, I wanted to start just introducing you all to Vultr. So, for many of you, Vultr might be well known. For many of you, Vultr might be completely unknown. So, Vultr is a very unique story. Vultr is a story of a group of engineers who, back in 1999, decided that they wanted to start a hosting business. And simply put, back in the early go-go days of the World Wide Web, help people stand up and manage server machines for hosting their websites and their web applications. And this group of engineer did not have any marketing, did not have any sales, but profitably grew a hosting business and starting to scale it globally, hosting some of the most demanding workloads on the planet from some of the most ambitious enterprises. One of the core hallmarks of the early days of Vultr was these engineers helping online gaming companies like Activision scale their worldwide gaming infrastructure, specifically major titles like Call of Duty. After about 15 years of growing and scaling the hosting business, this group of engineers decided that they wanted to invent a new cloud platform, a cloud platform built by developers for developers, a cloud platform that put in place all of the principles that they held so dear during those early 15 years, which is make the product so easy to use, make it so simple, make sure that it has lightning fast performance, and make sure that it's as cost efficient as possible so developers can just get their job done and get the best results possible at the lowest possible cost. This group of engineers didn't hire anyone in marketing. They didn't hire anyone in sales. They simply built a better mousetrap. And in 2014, launched the Vultr platform, which grew organically into the global powerhouse it is today. So where Vultr sits today is Vultr now operates in over 32 data center regions worldwide, um, accessing 90% of the world's population in as little as 2 milliseconds. So 2 milliseconds to 40 milliseconds. Again, this gets back to the roots of the company, supporting some of the most high intensity workloads on the planet that demanded the least amount of latency. And of course, the core value proposition of Vultr is making certain that not only do we have the reach of the hyperscale, but also offer, on average, better performance at the lowest possible cost. The whole goal for the Vultr platform is to be the most efficient hyperscaler to support your business. And the whole core mission of the company built around a core group of engineers who self-funded the company from free cash flow without taking a dime of outside capital, just tapping into the power of the open source community, tapping into an entire ecosystem of partners like dstack and Andre here, just simply built and scaled what we believe is the most exciting thing to happen in cloud infrastructure in quite a while. Most recently, we did start actually hiring people in sales, and we did actually start hiring people in marketing so that we could tell the world who we are and what we did, and we could better support partners like the dstack team here on today's webinar. In addition to starting to scale sales and marketing, we started to rapidly expand our product portfolio, specifically in the area of AI. We were first to market taking cloud GPUs including NVIDIA's top-of-the-line GPUs to market 3 years ago. And we are very proud to also offer freedom, choice, and flexibility in an open ecosystem of GPUs, supporting not only the top-of-the-line NVIDIA GPUs, but also top-of-the-line GPUs from AMD as well. Vultr is a core infrastructure as a service company. So we do not believe in the hyperscalers locking you into a walled garden. We are an open, composable platform, 100% API first. If you love Terraform, we love you back. So we are meant to be pure infrastructure as code, pure infrastructure services, integrating an entire ecosystem third-party services for all of your PaaS and SaaS services. This is all exposed via the Vultr marketplace, where we have hundreds of pre-built images that you can just instantly spin up on our infrastructure in as little as a single click. In terms of our core infrastructure services, this is our core cloud compute. This is all of your virtual private servers, from the smallest plan to the most optimized, highest intensity plan. We offer over 1,000 different subscription options in core cloud compute, so you can best match your workload requirements with the performance, the memory, the storage, and optimizations that you need to best fit your budget. In addition to a core cloud compute, we also offer the full range of cloud GPUs. This is all of your NVIDIA GH200s, your H100s, your H200s, your A100s, and more. We also offer the full range of AMD Instinct GPUs, both the MI300X and the MI325X. Uniquely, we're the only cloud provider that's now offering top-of-the-line NVIDIA and AMD GPUs both across any of our worldwide data center regions on customer demand. So any GPU, any scale, any location, that's our mantra. We want to unleash innovation everywhere from Brazil to India to South Africa to France. You name the region, we want to be able to support digital entrepreneurs wherever they live and work. In addition to core cloud compute and cloud GPU, we also offer bare metal as a service, extremely popular, available both for core cloud compute as well as cloud GPUs. And on top of our core CPU and GPU infrastructure, we of course offer managed Kubernetes, managed databases, and all of your optimized cloud storage, both for your traditional web applications as well as for all of your AI training and inference workloads. One of the hallmarks of Vultr, of course, is our networking, because we actually started out as a group of network engineers back in 1999. So we also provide all of your advanced networking options. So hybrid cloud, multi-cloud, private cloud, sovereign cloud, with all of the security, all of the compliance, with optimized performance. This is our bailiwick. This is our strong suit. We truly believe in making certain that we have the most secure, compliant platform that best integrates your data centers worldwide into our cloud infrastructure and connecting services to any of over 900 data center locations worldwide. So this is our core platform. This is our core portfolio focused on core infrastructure services, and then extending our infrastructure as a service and infrastructure as code with unique and compelling solutions driven by our partners like dstack here on the call today. We've talked a little bit about this. Our core mission is to be the most cost-effective cloud compute provider on the planet. Lowest cost, best performance, best security, greatest reach. As opposed to the traditional hyperscalers for core cloud compute workloads, most of our customers find that they save anywhere between 50 and 90%. And that's just in core North America and European markets. If you look at the cost differential and what we can actually do in places like Mexico, Brazil, Sub-Saharan Africa, Oceania, Korea, India, the list goes on and on. The cost savings are even more dramatic, and the performance gains even more so. Um, but beyond just the core cost effectiveness of the platform is just kind of our DNA. So as a company, it's a strong engineering culture, a strong culture committed to the open source ecosystem. And so what this means is that we believe very much in an open, collaborative partnership with our customers and helping them build amazing things. This means that our customers get direct access to our senior executives. They get direct access to our engineers. There's high touch customer support at every part of your customer journey. Our goal, again, is to make our partners successful, is to make our customers successful, and in so doing, learning how to make our platform even faster, even more cost efficient, to deliver more value to our customers every single day. So why we're here at the webinar here today is because, we've seen here at Vultr, going back to the early days when this group of engineers started the hosting business in 1999, saw the full development of the growth of cloud compute. From the early days, again, pioneering the build out of global infrastructure to support web applications and all of the first generation internet infrastructure people were putting in place around the globe, to the adoption of Kubernetes and reinventing the entire hosting business, building a next generation cloud platform to enable containerized workloads to be most cost efficiently scaled around all regions around the globe. And again, being first to market with Cloud GPU over 3 years ago, and now helping enterprises as they're moving forward with the mass scale adoption of new AI models to support streamlining both internal and external operational processes and their customer experience, helping to pioneer the build out of worldwide GPU infrastructure for both training and inference, with the full support of integrating containerized workloads, including containerized AI models that can be orchestrated across all of our 32 data center regions, which of course is why we are so excited and so committed to our joint partnership with Andre and the team at dstack here. Because as Vultr, as core infrastructure, we believe in helping all of our customers pre-compose their own best of breed cloud stack, integrating core PaaS and SaaS services that help them complete their task in building and deploying some new AI native application to drive a specific customer outcome. We are anti-monolith. We are anti-walled gardens. We are anti-hidden costs and hidden fees and billing statements that are foot thick. We believe only in the core principles of what makes developers happy: cost efficiency and getting things done and getting things done quickly, and making sure that you're totally future proof so you can consistently harness the power of the open source ecosystem and new innovation and build it into your cloud stack quickly and easily to deploy new and great things. And again, the greatest thing and the newest thing now available on the marketplace is dstack. And Andre, please tell us how amazing dstack is.
All right. Thanks, Kevin. Thanks for a great overview of Vultr. And yeah, with that, I'm super happy to dive into dstack. And let's start by understanding what dstack is and how this works. And the easiest way to think of dstack is as of a container orchestrator. It is similar to Kubernetes. However, it is more lightweight and it's actually tailored for the AI workloads. And you may wonder why we talk about containers. And Kevin mentioned when he talked about their Vultr's history that at a certain point when containers were introduced, that basically kicked off the era of cloud native architecture, and also helped for the cloud to become what it is right now. Containers are very important. Whether you are doing development, training, or inference, containers allow you to ship software that is both easy to reproduce, but also very easy to scale. And traditional orchestration frameworks such as Kubernetes or Slurm were designed in the pre-AI era at their big extent. And while they actually solve great the problem they were designed for, they have a number of significant limitations when it comes to running AI workloads. Whether you're familiar or not with Kubernetes, Kubernetes is a great piece of software which is standard de facto for anything that relates to infrastructure. It was designed for traditional software, and it offers an abstraction that is very easy to use when it comes to deploying and scaling software, traditional software. However, when it comes to running AI workloads, there's a number of limitations, and the main one is the low level of abstractions. Because when it comes to AI workloads, AI engineers are not exactly DevOps or RCE specialists involved in production. Instead, they focus actually on development. And when it comes to the development of AI models, you do development, training, and running inference, but you are not into the RCE basically stuff. And the other one is AI development also involves the efficient management of clusters and many other things which we'll speak about in this session. When it comes, for example, to Slurm, Slurm was designed in the HPC era. It was basically designed mostly in academia community for running simulations, even though Slurm is often used with AI workloads as well. It also has a number of limitations. It's focused mostly on scheduling, and it lacks development workflows and deployment workflows. And of course, the native integration with cloud means that someone, mostly administrators, have to manage certain classes and so on and so forth. And dstack is here to fill the gaps, and it offers a tailored interface, an interface tailored for AI tasks. And what is very important is that it offers all their tools, essential tools that AI engineers require. So basically, this stack covers development, it covers training and deployment, and then it covers the management of clusters and storage, and last but not least, the administration. What is also important to mention here is because this stack is a container orchestrator, it leverages the open source ecosystem and allows you to use any frameworks and doesn't limit you in terms of what tools or frameworks you can use. Anything that typically works, like any script that works locally or through SSH, would be easily used with dstack. Another important aspect of dstack is that it is 100% vendor agnostic. Practically speaking, it means that dstack offers a unified interface while it allows you to integrate with any cloud provider, any on-prem clusters, and of course use any hardware. In this session, in the demo part, we'll show how dstack can be used with AMD MI300X, but generally speaking, dstack supports any accelerators. And last part here is dstack is open source and it has MPL 2.0 license, which allows anyone, any individual or commercial enterprise to use this stack without any constraints. Next slide. All right, so this diagram helps us understand how this stack actually fits Vultr, and how it fits also your AI workflows. Let's look at the bottom of this diagram where we have accelerators. I mentioned NVIDIA and AMD as two primary accelerators supported by Vultr. At their layer on top of that, we have Vultr, which offers two types of clouds. One is private cloud, which includes their clusters for well, complex training workflows, and then the public cloud, which offers on-demand compute for your workloads. And on top of that, we have dstack as a container orchestrator. And what is important to understand here is that dstack abstracts out their Vultr interface and offers AI teams a unified and simple developer-friendly interface for managing any workloads. And this interface includes multiple things. Let me walk you through the main abstractions here. First one is dev environments. Typically, before you want to schedule some training or deploy some model, you want to interactively experiment with your code using your favorite IDE or terminal or notebook, and this is where the dev environments fit. With dstack, you can easily provision any dev environment, which you actually define declaratively. And then with dstack apply, you have that environment provisioned while the actual compute is running with Vultr, and you can use your favorite IDE to work with your code. And once you don't need that environment anymore, you can let dstack destroy that, or reuse the infrastructure under the hood by someone else on your team. Another interface that dstack offers is tasks. Tasks cover any sort of batch workloads, which can include a training job or fine-tuning thing, or any large model training task, which would run across a cluster of machines. Services help you run inference. Whenever you want to deploy a model, you can easily do that through services without being a deployment specialist or any special knowledge in Kubernetes. And then we have fleets. Fleets is a concept that, for example, is lacking with Kubernetes. Fleets allow AI teams to manage clusters, easily provision clusters of any size and requirements, and then reuse them with workloads. And the last one here is volumes. Volumes handle persistent storage. Typically, especially when you run some complex workloads, you also want to store your data and the persistent storage, and then basically use that data from the workloads. And because this stack is a container orchestrator, as we see, on top of that, we can use any frameworks, which includes PyTorch, VLLM, Meta, Stack, Hugging Face, ecosystem of libraries, NVIDIA, things like NIM, and any other things. Like I mentioned in the previous slide, anything that works on your, let's say, local machine or through SSH, any script will just work with dstack. And in the demo, we'll see how this actually works. And of course, containers mean that you are able to use your Docker image, means that whatever libraries or tools you use, you always can use your Docker image, which allows you to reproduce the workload at any time, and then, of course, control which versions are used. And to conclude this slide, this also means that you can use your data and run it in your Vultr tenancy, and you can develop or customize any models and then have them deployed in Vultr. Next slide. And with that, let's have a look at a very quick demo where I walk you through a couple of scenarios which give you a feeling of what how this stack can be used, and we'll look in particular into three actually use cases. But let me walk you through it. All right. Hope the demo works. All right, so it starts with configuring a Vultr backend. We create a simple YAML file where we provide Vultr credentials, which we obtain through their Vultr interface. Once the Vultr credentials are configured, we start dstack server. And with that, once the server is up, now anyone can use the dstack CLI or API to access the server. Let's look at the first example. Run in the dev environment. And for that, we would need one machine with MI300X. And to get this machine, we create a fleet configuration, and then we invoke the dstack apply command pointing to that fleet configuration. We always use dstack apply command wherever we want to provision a fleet or run a dev environment. That gives us this declarative control over anything we do at dstack. And once we do that, dstack would provision that machine in a private or public cloud. And once the machine is provisioned, we can actually use that for our workloads. Dstack fleet shows us the list of fleets created and with a status. So we see the fleet is idle now, means we can proceed with using that fleet. And now we will create a dev environment. This is a configuration file where we specify the requirements, the ID which we want to use, the Docker image. And now again, just like we did with fleet, we pass this dev environment configuration to the dstack apply command. -R, capital R, means that we're going to reuse an existing fleet and not provision a new one. And when we do that, in this particular case, dstack detects that we already have an existing fleet and we're going to reuse that fleet. Dstack handles everything under the hood, fetching your code, which you have in the current folder. It pulls the Docker image, which we specified. And then once it's running, we're actually going to see the output, the dev environment being set up, everything like ID extensions and Python environment, and it produces this URL, which we can now locally open to actually access the remote dev environment through our desktop ID. As we see, the VS Code which we requested is up and running, and it's actually running in Vultr's cloud, and we can see that their MI300X GPU is available. Means we can use the IDE to work, and then once the dev environment is not needed anymore, we can stop it. It asks us whether we want to stop the actual dev environment and not only detach. We say yes, and it stops the dev environment. And once we do that, the fleet we were using will become again idle, means it can be reused by someone else. And now we look at another use case, which is deployment of a DeepSeek model. And for the sake of this demo, we're going to use a distilled llama version based on DeepSeek. We specify their model commands, which we want to use to run the inference and other things. This stack allows to configure many, many different options. And once it's done, once the configuration is ready, we proceed and pass it to the dstack apply command. Again, we are using the -R argument to reuse the fleet. Confirm here, it shows us that it's gonna basically reuse the fleet which we created. And again, it will provision that service, will prepare the host and everything which is required. like pulling Docker image. This stack also handles a lot of things that makes it easy to optimize the workloads. It allows you to configure the storage for the cache, where the model is cached, and other things. Now, when the service is up, we see the URLs, which we can use to access the deployed model. And then we see also the live output of the VLLM framework, which we are using in this service. It downloads the model. For example, if we use in cache, it might use the cache model. If we don't want to wait each time we run the service. And then once the model is ready, we'll see how the inference actually working with dstack. But again, what you may notice here, we as AI engineer, we don't need any DevOps or SRE skills when it comes to running inference. And it also allows us to use any model, the base one or the fine-tuned version of that was created by our team. Right. Now the model is downloaded. Now it will basically load it. And we see that now it's ready. Here's the user interface of dstack, which we can use to access the model. Here we can see the model. And here's the playground where we can even play with that model. Of course, the model can be used through the API, dstack provides an open AI compatible endpoint, but of course we can also play with that model through the interface, which might be sometimes handy when we are experimenting with things. And basically we see that this model is capable of thinking, even though we are using the just distilled version of DeepSeek here. All right. Perfect. Yeah. Next slide. And with that, I'd like to conclude and walk you through the main points. First of all, dstack simplifies container orchestration because for AI development, it's very important to accelerate your AI team. So it focuses on data and models and doesn't focus on infra. Dstack is here to help with that. Then dstack actually leverages containers and open source ecosystem. And this is something that, well, I'm quite excited about. And as Karen mentioned, Vultr is a lot about not imposing a vendor lock-in on the customer and allowing the customer and the user use any open source stacks with Vultr. And this is where dstack fits 100% with Vultr. Because it enables you to use everything that the open source community offers to you. And we see that their development within this community is taking is making progress at lightning speed. Dstack enables you to use any accelerators, whether you are into NVIDIA ecosystem or whether you are an AMD ecosystem, you can use them freely, and you can also ensure that it's optimized. And here, you don't need to use managed or proprietary platforms that promise you that infrastructure is optimized. You can entirely rely on the open source stack, and at the same time, be sure that whether you are doing a very complex training or deploying a model at a great scale, dstack allows you to handle both. And well, of course, great thing here is that it doesn't have that Kubernetes complexity. Means that you don't have to bring a lot of DevOps and SREs to your team. You can get up to speed in a very short time and not being slowed down. As I said, it can be used at any scale, both inference and training. Dstack supports clusters, and it does it at optimized way. Dstack has a lot of features that help you save costs. Whenever you declare something like a fleet or a dev environment or any other workloads, dstack allows you to specify many things. For example, you can control the max price which you want to pay per hour, or you can specify what max duration for this training job or dev environment uh, gonna be. And if that is exceeded, then the stack would automatically kill the workload and will make the fleet idle. And also you can specify for how long, for example, a fleet can stay idle before the stack kills it automatically. One more thing which we introduced just recently is inactivity duration. For example, a dev environment. Sometimes whenever you experiment with something, you might, well, close your laptop and forget that you were actually using a dev environment, and especially if you are using a very expensive GPU, that might burn your balance on the cloud. And this is where dstack helps you by automatically detecting that dev environment is not used and killing that. And it's a lot of money if, like, especially during the months, if it's a large team that you can save here. And there are many different things related to costs. And yeah, of course, the biggest thing here is that this tech is open source, and vendor neutral. And with that, I'd like to finish my part and pass it over to Kevin.
Great. And thank you so much, Andre. And, like I said, I got to see the demo for the very first time. So I was super excited to see you walk through that. And I think the most amazing thing to me is that infrastructure can be complex. You're an AI engineer. You just simply want to get your job done. And the complexity of configuring and managing Kubernetes and all of the different services and networks and so on and so forth to power your AI model. You make it super simple and super easy for any engineer to just simply spin up a dev environment and get their work done. And this is all about scaling. So, and there are two dimensions of scaling. So, on the Vultr side, we want to make sure that you have the most scalable infrastructure to support your AI native applications. And that scalable infrastructure needs to deliver the best performance. It needs to deliver the lowest cost. It needs to have the greatest resiliency and the greatest security and compliance. And here at Vultr, we're the only ones that can provide you that scalable GPU infrastructure integrated with your core cloud compute for your AI native applications across 32 data center regions around the world. So, if you're building out a new portfolio of AI native applications that need to reach, the four corners of the world, Vultre's here to help. But the other dimension is you've got to scale your development teams. Your development teams need to move fast. They need to get things done. They need to spin up that dev environment. They can't actually have lots of loose development environments that are just, in a quiescent state, consuming resources when no one's actually using them. You need to be efficient about how you provision them with the dev environments, provision them with test environments, and then help them migrate their code easily and quickly out to the production environment. So together, Vultr plus dstack build that scalable infrastructure for you to roll out new AI native applications at scale, scaling your teams, scaling your infrastructure, and of course, making certain that we have the power of the open source community. So you can harness innovation not only in the software stack, but harness innovation in the hardware stack. Taking all the latest, greatest models from Hugging Face, any containerized model, seamlessly orchestrating it with with dstack on the past tier. And then, of course, on the back end, any GPU from AMD, any GPU from NVIDIA, it's seamlessly scaling on the back end. And of course, we like to think here at Vultr we're pretty friendly people because we think friendliness and openness and collaboration is the key to innovation and the foundation of the open source community. So yes, we're very proud to be open source friendly, and that's why we're so excited to work so closely with the Linux Foundation and with our friends at dstack and with all of our marketplace partners around the globe. So with that, we have a whole host of helpful resources that hopefully you've seen as we've posted them into the chat channel for you all, including documentation, tech talks, things that'll help you actually get things done. And of course, you can learn more here at the QR code that's provided here on the slide. So pick out your phones, open your cameras, good list of resources to help you with. And speaking of being helpful, Andre, I think we have a couple of questions coming from the audience. So if you don't mind if I threw a couple of questions your way.
Absolutely.
Okay. Question number one is you had made reference to Slurm being originated in HPC workloads for scheduling. Of course, now Slurm is now being used in the context of Kubernetes. Could you tell us why not a Slurm Kubernetes combination and why dstack?
All right. Yeah. Again, quick disclaimer here. I will provide my perspective as a dstack core contributor. So bear with me. But couple of things. Number one, I just want to mention that Slurm is an amazing tool. It was designed for. And this Slurm is mostly used by research labs historically because of the academia background and also because Slurm is working really well when it's actually tuned for running large model trainings. And as I mentioned in their demo, there are a couple of things, quite a few things that we can call disadvantages. So number one is Slurm is let's say not a cloud native tool in terms of having this necessity to be administrated and managed by someone.
Mhm.
Means that you need to bring someone who would take ownership of that Slurm cluster and manage it, and it requires significant effort. That's one. Second, Slurm only covers training, and it's especially good with large model training. However, when you do AI development, there are so many other things. First one is provisioning clusters. Today you need a 10 machine cluster. Tomorrow you need 100 machine cluster. Another day you need just on-demand machine. And Slurm doesn't actually offer that like
Yeah.
from the box. You either have to do it all manually with Slurm each time, or you would need Slurm to be managed by something. Then Slurm doesn't offer dev environments out of the box, which is a pretty great tool, especially for interactive work. Before you run any model or training, you need to do development. Ideally, you're using your favorite IDE, and this stack offers so many different things that help you actually run those dev environments. Then also inference. Sometimes you need to run inference, and inference means that you want to run a model as an endpoint and then have this model auto-scaled, but you don't really want to go to Kubernetes because you are doing development, you are not doing production-grade deployment. Imagine you are working on a, let's say, a product concept, and you'd like to use one of the models which you've trained or one of the open source models. And with this stack, you can choose any model and then have it deployed and even auto-scaled. And then you get this OpenAI compatible endpoint, which you can easily now share with the rest of the team. The other team can use that endpoint to integrate it into the product and build a RAG on top. And all of that is taking place at the development stage and not the
Yeah.
production stage,
Great point.
which accelerates like 10 times the development experience.
Yeah, I think those are great points. I mean, you talk about Slurm, and just if I make an editorial comment, you're in a research lab and you have a lot of researchers, and they need to access essentially the centralized compute resources, and you need a very fast and efficient scheduler for all of those jobs. And in the early AI market, when people are building the frontier models, you had these very, very large supercompute clusters, and it was all about, best sequencing and scheduling the jobs and making sure that everything worked. But, we're in a new era, right? We've got to support kind of the mass development and mass adoption of, you know, AI to support all of our, internal and external applications. And so principles of cloud native engineering have to come to bear, which, number one is, resources should be ephemeral. You should be able to quickly spin up a dev environment. You should be able to quickly spin down a dev environment. You should be able
Absolutely.
to quickly spin up a test environment. I mean, did we learn nothing with Amazon? I mean, that's what Amazon taught us. Just spin up a cheap and cheerful EC2 instance, spin up a cheap,
Yeah. And
cheerful S3
also,
instance, and then destroy it when you don't need it. And no one needs to be involved. It's a simple API call. Like, that's what you do. Like, you make it so easy to spin things up and just start scaling it. And I think you made also a really good point about Kubernetes, which is, maybe Kubernetes is perfect for your production environment. But what about that small little dev team that's like, oh my God, DeepSeek? What if we were to build a whole new agentic AI framework and leverage DeepSeek? Let me just quickly spin up a dev environment, take down DeepSeek, test this thing out, create the endpoint, let two or three different other teams quickly, prototype a RAG application calling that endpoint. You don't want to slow them down by having to figure a whole DevOps pipeline and figure out all of the complexity of, standing up and managing all the Kubernetes, right? Just
absolutely.
let them experiment. Like maybe they do that over the weekend, right? But then maybe when it goes production, then yes, it goes into the formal platform engineering team, platform engineering process. It all goes in production readiness on Kubernetes. So I think that was a really powerful point that I might have actually missed before, Andre, to be honest with you. Um, a lot of the power and the flexibility comes in the fact that let developers move fast. Don't put
Absolutely, Kevin.
in the
Thanks
way.
for mentioning that. And also maybe add a last point here. This tech is used not only by small teams, but it's actually mostly used by large teams. And when we also speak about Kubernetes, we forget that Kubernetes is not for free. In terms of the development effort that a company needs to invest into making their Kubernetes use efficient. We have quite many teams that share a lot of insights how they actually use Kubernetes for managing their infra. And it was so surprising to know how much effort you need to invest into making Kubernetes usable by AI teams. You have to invest a lot in custom operators and writing custom code that the Kubernetes cluster that you operate actually runs efficient. And one of the specific focuses which we have within the team is to bring those things that many large platform teams build as a custom solution on top of Kubernetes. They are available out of the box with dstack.
Right. Right. I mean, I think it's a really, really powerful point. And, it might not even be, mutually exclusive. Very large enterprises, very large distributed team get all of the flexibility and the efficiency and the speed that dstock offers. But yes, when something's production ready, then it gets formally taken over and deployed in a proper way on Kubernetes by the SRE team and so on and so forth. So I think it's a really powerful point. And, Andre, we have so many questions in the chat, but I know that we're actually at time. So for those of you, I think we have a couple of dozen questions in the chat. So we do apologize. We are going to have to follow up with you all one-on-one, which we are excited to do. And we do hope all of you, go to vultr.com, spin up a trial account. Please contact us. Please contact Andre. Again, you see a lot of resources here at the QR code to spin up dstack on Vultr and get started today. Andre, any final words from you?
Sure. So I'd like to mention once again, of course, that this deck is an open source project, which actually means that we welcome very much contributors. And contribution can come in different ways. Probably the most favorite way, at least from my perspective, is feedback. Feedback is it's a quite an easy way to contribute because you are using the product for solving the problem you have at hand, and then you come up with something that you'd like the product to be improved around, and that's how we make this deck better every day. So I'd like to encourage everyone to give a
Yeah.
try to this deck and contribute with feature requests and bug reports, and just join the Discord channel to share the feedback. And of course, if, for example, well, you'd like also to contribute with code, we do have a contributing guide, and it might take some time to, well, get through the code. And we also have some issues where you could start contributing, and we would very much encourage that.
Awesome. Well, I think those are great parting words. A shout out to all open source developers, and here at Vultr, we like to use the term open development because feedback is the best source for driving innovation. And the more people use the product, the more people experience the product, the more people stress test the product, and then actually give us that feedback that helps us make a better, more cost-efficient platform so we can lower the cost curve as we love to do year over year after year. More compute, lower cost, year over year. That's our mission here at Vultr. Andrew, thank you so much for your partnership. Thank you so much for the webinar. And thank you so much to the amazing team at the Linux Foundation. We're so honored to be partnered with you today and so honored to have you as our hosts for today's webinar. So thank you.
Thank you, Kevin, and thanks Linux Foundation for having us.
All right. Thanks so much, Kevin and Andre, for your time today. And thank you for everyone for joining us. As a reminder, this recording will be on the Linux Foundation YouTube page. We hope you'll join us for future webinars and have a wonderful day. Thank you. Bye.
Thank you. Take care, everyone.
Bye.